Hello everyone, welcome to the new lecture. So in this lecture we have to discuss about the transformer selection part 2. So after the end of this lecture you would be able to understand how to do the sizing of transformer. So in this lecture I will show you the transformer sizing calculation. So let's start. So now for the transformer sizing, here I have taken one problem. So with the help of this problem only we have to discuss that how we can do the sizing. Okay, so it is easy for you. So in this question, see what is given. We need to calculate the size of transformer having lighting load 100 kilowatt, raw power load 200 kilowatt, AC load 250 kilowatt, lift motor load, water supply motor, firefighting motor. So here the capacity is given. Okay, now electrical load value is given. Now the first step for the transformer sizing calculation is what? First of all, we need to calculate the total connected load. So what is connected load? Try to understand. Connected load refers to the total electrical load connected to a power supply system and typically measured in kilowatt or megawatt. In short, you can say MW, and it encompasses all devices, appliances and equipment that are simultaneously connected and drawing power. Okay, so these include lighting, heating, cooling system, machinery, appliances and any other electrical device in a facilities. Okay, so the electrical load is essential for sizing electrical infrastructure such as transformer and distribution system to ensure they can handle the total power demand. Okay, so first of all, here we are going to find out the transformer sizing. So first step is to calculate the total connected load. Okay, so here you can see the total electrical load is given. Okay, for lighting load, raw power load, just add it each and every one. To find out the total connected load, just whatever lighting load and power load is given, I have added. So when you add, you will get the value 632.06 kilowatt. Okay, this is your total connected load. Okay, so understanding the connected load helps in designing and managing electrical system efficiently, preventing overloads and ensuring a reliable power supply. Okay, so remember this thing. Now the next one, we have to add 10% extra for future demand purpose. So add it. So here you will get the total demand is equal to total connected load plus 10% of that total connected load. So we get how much now? 695.266 kilowatt. This is our total demand. Now the next step, now we have to calculate the maximum demand based on the demand factor of the building. Now try to understand what is maximum demand. So maximum demand refers to the highest level of power consumption within a specific time frame. Okay, so it represents the peak load that a facility or power grid experiences during a defined period, and it is usually measured in a minute interval, 15, 13 or 60-minute interval. Okay, so understanding maximum demand is crucial for efficient power system planning, and it's ensure that the infrastructure can meet the peak power requirement without compromising reliability. Okay, so here we need to calculate the maximum demand based on the demand factor of the building. Now demand factor is what? It is the ratio that compare the maximum demand on a system to the total connected load. Okay, so see, in simpler term you can say the demand factor indicates how much of the total connected load is expected to be in use simultaneously during the peak demand period. Okay, so see, here it is given, the standard demand factor is given. Okay, for residential building and commercial building, how much demand factor we have to take, because as based on demand factor only we have to calculate the maximum demand value. So remember, the demand factor varies for different types of building and their associated load. Okay, so here I will show you, tell you some general guideline for demand factor in residential, commercial and industrial building. So for residential building, See, the demand factor range is given. Remember, demand factor for residential building range from 25% to 50%. Okay, this is because not all electrical appliances and devices are typically in use simultaneously in residential. Okay, for example, if a residential area has a total connected load of 10 kilowatt, just I am taking the example. Okay, if a residential area has a total connected load of 10 kilowatt, the actual demand during peak period might be in the range of 2.5 kilowatt to 5 kilowatt. Okay, depending on factors such as lifestyle, habits, and appliances usage pattern. Okay, next thing, for commercial, see, demand factor range is given 50% to 75. So demand factor for commercial building can vary, but generally fall between 50% to and 75%. Okay, commercial establishment may have more simultaneous usage due to office equipment, lighting, HVAC system, and other business related activities. So for instance, if a commercial building has a total connected load of 100 kilowatt, so the actual demand during peak period might be in the range of 50 kilowatt to 75 kilowatt. Okay, next one we have a industrial. So for industrial building, how much we have to take the demand factor? 75% to 90%. So industrial building often have higher demand factor, typically ranging from 75% to 90% or more. Okay, industrial process may require a significant portion of the connected load to operate simultaneously. Okay, if I take an example, let's say if an industrial facility has a total connected load of 500 kilowatt, so the actual demand during peak period might be in the range of 375 kilowatt to 450 kilowatt, because between these 75 to 90% we have to take. Okay, so there are general guidelines, and actual demand factor can vary based on a specific usage pattern, energy efficient technology, and local regulation. Okay, so I hope now all of you understood. So suppose in our project we are assuming we are designing for commercial building, so demand factor 50 to 75%. So here you can see, here I have assuming we are designing for commercial building, so the maximum demand factor 75% of total demand. Okay, to calculate the maximum demand factor value, 75% of total demand. Okay, so when you calculate total demand, already we have calculated 695.266. Okay, so here you will get 521.44 kilowatt. Okay, so this is your maximum demand factor value. Now we have to calculate the kVA, kilovolt ampere, required based upon power factor. So how to calculate, all of you know, this is the formula. If you want to convert kilowatt in kilovolt ampere, this is the formula. Okay, kilowatt per power factor. Why I am converting? Because generally the transformer sizing is given in kilovolt ampere only. Okay, or MVA, mega volt ampere. So just here I have taken the maximum demand value 521.44 divided by power factor. So here you can see power factor I have taken 0.8. I think all of you know about the power factor. Power factor is a measure of how effectively electrical power is being converted into useful power work output in an electrical system. Okay, so it is a dimensionless number between 0 and 1, or it can be expressed as a percentage between 0% and 100%. Okay, if you want to calculate the power factor, so we have a formula for that: real power in kilowatt divided by apparent power in kilovolt ampere multiplied by 100. Okay, so now this power factor, how much we have to take the power factor for commercial building? So remember, for commercial building it is generally recommended to maintain a power factor as close to 1 or 100%, you can say, as possible. Okay, so a power factor close to 1 indicate efficient utilization of electrical power and help minimize losses in the electrical system. So that is why here I have taken 0.8. Okay, close to 1. So as per that we have got 651.8 kilovolt ampere. Now we have to calculate the maximum kVA required based on the derating factor. Okay, So what is actually derating factor for transformer? So try to understand. This derating factor for a transformer is a correction factor applied to its rated capacity to account for various operating conditions that may deviate from standard or ideal condition. Okay, so derating is important to ensure the transformer reliability and longevity when exposed to factors such as high ambient temperatures, altitude, or non-sinusoidal load currents, etc. Okay, so here we have a common derating factor include like temperature derating factor, altitude derating factor, harmonic derating factor, load derating factors. Okay, so here the specific how much value we have to take derating factor. Remember, the specific derating factor depends on the transformer design, manufacturer specification, and the operating conditions. Okay, so here what I have done, here I have taken derating factor of transformer 90%. As I told you, to determine the specific derating factor for a particular transformer, it is crucial to refer to the manufacturer technical documentation and guideline. Okay. Transformer datasheet usually provide information on derating factor for different operating condition. From there you will get this detail. Okay. So I have taken 90%. As per that, see, maximum kVA is what? Whatever maximum demand factor you have calculated in kilovolt ampere divided by derating factor of transformer. So here you will get 724.22. So this is your capacity of transformer, but we know that in market we have some standard size of transformer, maybe 724.22 is not available. So my proposed transformer is now I have taken 1000 kVA. Okay, so in this way we have to find out the capacity. So now I hope this is all about the transformer sizing calculation. Okay, if this video is important for you, please do not forget to like, subscribe, and share this video to your friend. Okay, I hope all of you enjoy the session. See you in next one.